everyone, I'm myself Dr. Dipti, I'm MD PhD Physiology and your educator for Physiology. Today we'll discuss about ECG. Today's class we will discuss about recording of ECG. Now, before starting the class, I would like to inform you all that you will get all my notes or all my lecture notes in soft copy as well as in hard copy. To get the soft copy, you have to download the application Vesalius and you have to subscribe for the same. Let me check I'm audible. Okay, fine. And to get hard copy, you have to order my book, that is Physiology Notes. Okay. Now, we also have started our WhatsApp group number to join the WhatsApp group, that is 78638226668. I repeat the number, that is 78638226668. Okay. Link for joining the WhatsApp group, that is also there in the description box. Link for my application, link for my book and the WhatsApp group, they all are given in the description box. Now, let us start with electrocardiogram. Now, what is this electrocardiogram? It is the graphical recording of electrical activity of the heart. This electrical activity that is obtained by placing electrodes on the surface of the body. You can see, you might have seen the recording of ECG. Okay, so here we are placing the electrode on the surface of the body and we can get the recording. Now, what is electrocardiography? It is the method for recording ECG, that is electrocardiography. Okay, and this is extracellular recording of the summated electrical activity, whatever electrical activity that is there because of contraction of heart, that is summated and that is recorded extracellularly. Okay, now heart acts as a dipole. How we can get the electrical activity? Because heart acts as a dipole. Two terminals of the battery, one is negative, other is positive. Which one is negative? The part which is depolarized, that is negative. How? Because when the part is depolarized, there is positivity inside and negativity outside. You can see here, because of the depolarization, there is entry of sodium ions, positivity inside, negativity outside. And when the negativity is outside, then you can say this is the negative terminal of the battery. And the part which is not depolarized or non-excited part, that is the positive part. Okay. Now, our body contains a large quantity of electrolytes in our body fluids. So you can say that our body fluids are good conductor of electricity. Okay. So electrical changes, they occur in the heart. They can be recorded if we place electrode on the surface of the body. Okay. So this electrocardiograph, it is the machine. Electrocardiography, that is the method. And electrocardiogram, that is the recording which we are taking. This is electrocardiogram. So these are the basic terminologies you must know. Okay. Now, regarding history, William Einthoven, he was a Dutch physiologist and he invented this electrocardiography, and so it is known as, so he is the father of modern electrocardiography. Okay, and he was awarded for his this contribution by Nobel Prize in 1924. Okay. Now, what are the uses of ECG? Important thing here. ECG is used for anatomical orientation of the heart, how the heart is located, to find out the relative size of the chamber, whether there is hypertrophy of the any of particular chamber, left atrium ventricle or right atrium ventricle. Okay, we can get the idea about disturbance of the rhythm as well as disturbance in the conduction. We will discuss different changes in the ECG in all these situations. Okay, also we can get the idea about the influence of certain drugs like digitalis. We can get the idea about effect of the electrolyte concentration. Also we can get the idea about efficiency of pacemaker if we have placed in the heart. Okay, ischemia of myocardium, that also we can diagnose if it is present, and also we can find out the location, extent as well as progress of the myocardial infarction. Okay, so all these are the uses of ECG. Now, what is the method for recording ECG? We have two types of ECG machines, one that is string galvanometer and other that is radio amplifier. And ECG is recorded by, you can see here, this is the simplest and smallest ECG machine. Nowadays this kind of ECG machines are available. So ECG is recorded on ECG paper and this is fitted on the machine. You can see here, this is the standard ECG paper. Okay, now we'll discuss ECG paper. On the ECG paper, standard ECG paper, we have horizontal, you can see here, these are the horizontals and horizontal, and these are vertical grids or lines. Okay, Now this horizontal and vertical lines, they are 1 millimeter apart. You can see this is 1, 1, 1. Fine. Okay, and this is also 1. So what is the size of square? These are squares which are formed 1 millimeter by 1 millimeter. Fine. This is the size of square. Okay. Now another important thing here is your paper moves at a speed of 25 millimeter per second. In 1 second, 25 small squares are moving here. Another important thing here is on horizontal axis, this it represents time. You can see here time. Okay, and what is the calibration of time? You can see 25 millimeter in 1 second. Okay, means 25 small square in 1 second. Okay, so one small square is equal to 1 upon 25 is equal to 0.04 seconds. So you can see here, this is the way how we calibrated here on the horizontal axis. Okay, fine. Then on the vertical axis, here this shows voltage. One small square is equal to zero point 0.1 millivolt. So 5 small square is equal to 0.5. Another important thing here is at the end of 5 small squares, you have a thick line, this one. So this forms a big square. You can see here, small squares are there. So in one big square you have 25 small squares. Fine. Hmm? And big square size is 5 millimeter by 5 millimeter. Small square size, that is 1 millimeter by 1 millimeter. Okay, so these are the calibration. Now this ECG paper, that is heat sensitive plastic coated paper. So whenever on this paper we are moving the stylus gets heated. So when heated stylus moves, what does it do? It turns the paper black, and we will get the recording like this. Okay, speed of paper I already told you, 25 millimeter per second. So this also we have discussed, one small square is equal to in 1 second 25 small squares in 1 second. So one small square is equal to 1 upon 25, and one big square is equal to, this is 0.04 multiplied by 5. Okay, so 0.20 seconds. Same way on y axis, one small square is equal to 0.1 millimeter, and point 1 sorry, one small square is equal to 0.1 millivolt. So one big square is equal to 5 small square is equal to 0.5 millivolt. Okay, so these are the calibration. Now there are positive and negative deflection you find when you are recording ECG. You can see here this one. So what is positive deflection? Any deflection on the record above the baseline, that is positive. Why you have positive deflection or positive movement? When active electrode is positive as compared to indifferent electrode, you will find this kind of positive deflection. And spread of excitation, or you can say this depolarization wave, when it spreads towards the positive electrode, again you will get the positive deflection. Fine. Negative deflection, opposite. Any deflection of record below the baseline, this one, this is negative deflection. Okay, and here it is because when active electrode becomes negative as compared to indifferent electrode. Okay, or you can say spread of excitation wave away from the positive electrode, you will get negative deflection. Okay, then biphasic, that is partially positive, this is biphasic, and partially negative. Okay, when uh, when do you have biphasic wave? That is present when the depolarization wave is moving perpendicular to electron, and there is isoelectric line, means no positive or negative deflection, that is isoelectric line. Okay, now procedure of recording ECG. ECG is recorded by ECG machine. Okay, that is electrocardiograph, and we use galvanometer with voltage amplifier recording system. There are two methods for recording. One, that is bipolar method, and second is unipolar method. What is bipolar method? Here both the electrodes are active, and in unipolar method one electrode is active and another electrode is indifferent. We will discuss how is it produced. So first, starting with bipolar method. In bipolar method, as I told you, both the electrodes are active, and one electrode is connected with the negative terminal and other is connected with the positive one. Okay, now Inthovan, as we have discussed, he was the father of modern electrocardiography. So Inthovan has made a triangle. So here Inthovan assumed that our body is like electrically homogeneous plate. Okay, and this is the whole is homogeneous plate, and right shoulder, left shoulder, and pubic region, this three. Okay, they are the corners of equilateral triangle. He made one equilateral, equal sides, okay, equilateral triangle. And this right shoulder, left shoulder, and pubic region, they are the three corners of this equilateral triangle. And our heart is in the center of this triangle. Okay, so this triangle is known as Inthovan's triangle. Okay, so accordingly, we are placing the electrodes. Another important thing, if we are placing the electrode not on the shoulders and pubic region, instead of that, we can also place these electrodes on the arms, left arm, right arm, and left foot. Okay. So for convenience, we are placing the electrodes on this left arm, right arm, and left foot. We are not placing electrode on the right foot because we are making triangle. Okay. Fine. So these two active electrodes you can see here are placed, okay, and electrodes are connected to this electrodes. They are connected, connected to your left arm, right arm, and left foot. Okay, and bipolar leads we are recording here. This bipolar leads are also known as classical limb leads or standard limb leads. Okay, now. Which are these three leads we will discuss? First of all, you can see this is the diagram I have taken from the standard textbook. You can see here this is lead 1. So in lead 1, what do we do is we are having two active electrodes. One that is connected with the right arm and other to the left arm. Okay. So right arm is connected with negative terminal and left arm is connected with the positive terminal. Okay. And this electrical activity, it moves from negative to positive. So this is the direction. In lead 2, sorry, this is lead 2, this is lead 3. In lead 2, two active electrodes are there. One is connected with the negative, that is right arm, and left foot is connected with the positive terminal. And in lead 3, left arm is connected with the negative terminal and left foot is connected with the positive terminal. So this way we are getting these three leads. Okay. Now, what is this Inthovan's law? Inthovan's law states that at any given instant, sum total of the potential in lead 2 is equal to lead 1 plus lead 3. So sum total of the potential in lead 1 plus lead 3 is equal to lead 2. I will explain how. You can see here. If we are placing lead 1 as I told you, it is like this. Negative terminal to right arm, positive to left arm. Okay. So we will place here lead 1. Left arm is positive and right arm is negative. So we will place minus sign. Okay. This is lead 2. This is lead 3. In lead 3 now we are talking left arm is connected with the negative and left foot is connected with the positive. So again now add lead 3 here. Left arm, it is negative, so place the sign negative here, plus left foot. Okay, and you will get this one, right arm negative and left foot, and this is your right arm negative, left foot positive. This is your lead 2. Okay, so this is the same thing here, it is depicted. Fine. This is Inthovan's law. Now unipolar leads. Unipolar recording, here what we do is, instead of making both the electrodes active, two electrodes are used, but one is active or exploring electrode and another is indifferent electrode. Means second electrode is placed at zero potential. Okay, how the zero potential is created? By connecting electrodes placed in the right arm, you can see here, left arm and left foot. All these three are connected to particular resistance. Okay, to the central terminal with the resistance. This resistance is calculated. This is 5000 ohm. Okay, and what is how the zero potential is created? In a volume conductor, sum total of the potential at the point of equilateral triangle with current source in the center is zero at all times. Therefore, if this electrode is placed in the left arm, right arm, and left foot, they are connected to the central terminal with the resistance, we can have this zero potential creation. Okay, now unipolar limb leads are again of three types. One, that is chest leads, unipolar precordial leads. Second, that is unipolar limb leads, and third, that is augmented unipolar leads. We will discuss starting with first, that is unipolar precordial leads or chest leads. There are 6 precordial leads are there, V1 to V6. Now V1 we are placing here, that is in the right fourth intercostal space near sternum. V2, that is in the left fourth intercostal space near sternum, but left side, you can see here, this is V2. V3, that is between V2 and V4 here in between. Okay, between V2 and V4. Then V4, that is located in the fifth intercostal space here in the mid-clavicular line. This is mid-clavicular line here. V5, fifth intercostal space in the anterior axillary line. And V6 in the fifth intercostal space at your mid-axillary line. Fine. So these are 6 leads which are uh, produced, or 6 precordial leads placement. Okay, now characteristic features of unipolar precordial leads. Okay, they influence electrical activity of the part which is near to the heart, like V1 and V2. You can see here V1 and V2 are here, and you have right ventricle here, so V1 and V2 reflects the right ventricular activity. Okay, and QRX complex here, that is small and upward, like this. Q is this way, small, and upward this way. Then V3, V4, they reflect the activity of both the ventricle and interventricular septum, this one. And V5, V6, they denote the activity of left ventricle, left and lateral wall. Okay. Now, as we pass from V1 to V6, you can say that, you can see here, R wave height gradually increases. Okay, and S wave size gradually decreases. You can see here, this one. This is R, this S1 gradually decreases. So in V3, R and S waves are equal. So R wave and in V6 and S wave in V1, they denote the left ventricular activity, whereas R wave in V1 and S wave in V6, they denote the activity of right ventricular. Okay, and P is always positive. Why P is always positive? Because the atria are located posteriorly, so excitation wave moves from SA node to AV node, so that is posterior to anterior, and that is always positive. Okay, then unipolar limb leads. This is again same thing. Unipolar limb leads are here VL, VF, and VR. Here exploring electrode, suppose we are recording VL. So exploring electrode or active electrode is present on the that limb, particular limb. Okay, and indifferent electrode, that is at zero potential. Okay. So in VL, active electrode is placed on the left arm. In VR, active electrode is placed on the right arm. And in VF, active electrode is placed on the left foot. Okay, and zero potential we have discussed how to create, because all these three are connected to the resistance. Nowadays, these unipolar limb leads are not used. Instead of that, we are using augmented unipolar limb leads. They are AVR, AVL, and AVF. Means here the potentials are augmented. How to create this augmented leads? Here what we do is one limb is connected. Suppose we are talking about AVR. Then you can see here AVR. So right limb, right arm, that is connected to positive terminal, and remaining two. So this is your right arm that is connected to positive, and remaining two are connected with the negative terminal. What is the use of augmented leads? Here you can see we can augment the potential 50%. So vector of augmented lead, that is equal to 3 by 2 vector of the unipolar lead. How? That we will discuss with the vector cardiogram. I am not going in detail of that augmentation. Okay. Now, this is also we'll discuss. Now, what is the importance of 12 lead ECG? 12 leads. Which are those 12 leads? 6 precordial leads, V1 to V6, unipolar augmented leads, AVR, AVL, and AVF, and bipolar standard limb leads 1, 2, and 3. So these are total 12 leads ECG. Okay, so now what is the importance? When we are talking about the limb leads and augmented leads, they reflect the depolarization of heart in the ventral plane here, ventrally. Okay, and lead 1 and AVL, they are known as, this is, you can see, lead 1 and AVL, this two, these are known as left lateral leads. Okay, means this leads, they denote activity of the left side of the heart and lateral wall. Okay, lead number 2, you can see here 2, this is lead number 3 and AVF, they are known as inferior leads. You can see here inferiorly, they denote the electrical activity in the inferior wall of the heart. Then lead VR and AVR, this is the direction, AVR, this one. Okay, that denotes the activity of cavity of ventricle. Fine. Now another is precordial leads, V1 to V6, they reflect electrical activity of the heart in horizontal plane, this one, horizontal plane. V1 and V2 are known as anterior leads. Okay, and they are formed by right and left ventricles. V5, V6, these two are known as left lateral leads. Okay, so this is about the importance of different leads. Okay, so this is all about, we have discussed recording of ECG and importance of different leads of ECG. Okay, again, if you wish to get all my lecture notes, you can download the application Vesalius and subscribe, and you will get all the notes in soft copy. For getting notes in hard copy, you have to get my book that is available on Flipkart and Amazon. Link for all that is given in the description box. Again, you can join my WhatsApp group, and the number is 78638226668. WhatsApp group link is also there in description box. Okay, thank you so much. If you like my video, you can like it, you can share with all your friends, and you can subscribe our channel. Thank you.